learn about quadratic inequalities. Okay, we've done inequalities before. So basically we did it over here, I think. We'll learn about absolute value inequality and as well as linear inequality. Like these ones, inequalities. Right, how we solve this. It's same as how we solve the equation. But when it comes to quadratic inequality, it's a little bit more tricky. So let's go through the procedure. So there's a procedure here. Let's go through them. So the procedure says, move all terms to the left-hand side. We've got it like this. Some quadratic expression bigger than 0. Solve the equation left-hand side equal to 0. Okay, let's do that first. So what we do is, the first step is to solve. Okay, so the first step is to write this equals to 0. And we're going to solve it. Solve. Now, how do we solve this? We just have to factorize to solve. So we get x. Now, what are the numbers which multiply to get negative 6 add to get 1? What would it be? Say again, 3 and negative 2. So that gives us negative 3 and 2. All right, that's the second step. So we did the second step. Make the right-hand side, left-hand side 0. Now plot this solution on the number line. All right, so we're going to plot it. So we've got two numbers, negative 3 and 2. Just plot them on a number line. All right, after we plot the number on the number line, we're going to pick a number in each of the interval. So we got, when you have these two numbers plotted, it divides the number line into 3 parts, right? So we're going to pick any number within this part. So give me a number that's less than negative 3. What number would it be? Negative 4. Give me a number somewhere between negative 3 and 2. Yep, I prefer 0. It's easier. How about the last one? 3. Okay, like this. And then what you need to do, what's the next one, is to check these numbers using the inequality in 1. So basically it's this one, right? So we're going to substitute. We're going to substitute x equal to negative 4 into the inequality, into this thing. So we into this. So we just check negative 4 squared plus negative 4 minus 6 is that greater than 0. We're just checking. Check. Right? So what do you get? If you do that on a calculator, what do you get? No, you won't get 0. Well, do it. 16, right? Minus 4 minus 6. What's that? 6. Is that true? If it's true, please tick that it is done, right? That's tick. So if it's true, you tick it. Means it's in the, means this, any number less than negative 3 will make that bigger than 0. And then we'll check the next one. Let's check 0. So we substitute 0. Next we check substitute x is 0. So we get 0 squared plus 0 minus 6, bigger than 0. And what do you get? You get negative 6, isn't it? Right? Is that bigger than 0? True or false? False. So that means cross. And then we've got one more number to check. Check 3. Okay? Now check 3. So check x equal to 3. So we get 3 squared plus 3 minus 6 is that greater than 0. 9 plus 3 is 12. 12 minus 6 is 6. Yes. So what do? We tick it. So that means your final answer will be x less than negative 3 or x more than 2. So your answer will be this. So you get x less than negative 3 or x is more than 2. Yeah, that's your answer. So you have two places. That's what we have to check. Different from linear inequality, there's only one number. But when there are more than one number, you have to check each part. Okay? So the answer is x less than -3 or x more than 2. Question? Yeah, all good. Let's do the next one. We're going to follow the same procedure. Okay. Let's do the next one. What's the first step? Yeah, move all terms to the other side. So I'm going to move the x squared to the left, bigger than 0, right? That's the first step. Okay, what's the next step? Solve this thing to find the numbers. So let's solve it. So we get, how do we solve? We just move the x squared back, and then we square root, plus and minus, right? Oops. So what's square root of 9? Okay, good. That's the second step. Now what do we do next? What do we do with these numbers? Plot it on the number line. Very good. Plot them, of course, in order from left to right. Yep, the small and right. And then we pick 3 numbers. We're going to pick x equal to -4, and 0 is always easy to, it's easier to substitute, and 4, right? And we're going to check. All right, let's check. Now remember, using this, right? Check against this. So we substitute -4 in. So write 9 minus 4 square. Oops. So write 9 minus -4 square is bigger than 0. Well, 9 minus -4 square means 9 minus 16. What's 9 minus 16? -7, right? Is it positive? Is it bigger than 0? No, right? That's wrong. So it's not in this region. And we check 0. Let's check. 9 minus 0 square. Oops. Is that bigger than 0? 9 bigger than 0? Yes. Good. So what do we say? We say it's true, right? So we tick. We tick. And then next one we check 4. 9 minus 4 square is bigger than 0. You get -7 like we did before, right? It's false. So it's not in here. So now we have to describe the inequality. Now the inequality is going to be between 3 and -3, isn't it? Somewhere here. But this time it has an equal sign, so you write includes. Right? So that means you're going to write x in between 3 and -3. But this time with the equal, right? Whereas the other one is less than, so you don't put the equal, right? So the other one you just put without the equal sign. Any questions? So it's very easy. Just solve it, check it, and write down the answer. Okay? Any question, any comment? All good? That's quadratic. Yeah. Yep. One statement for this because it's in between. But if it's not in between, see, that's separate ways, so it's separate inequality, yeah. But if it's in between, always better to write it as one. Yeah, it's clearer. Okay, any question? Good? All clear how to solve quadratic inequality? Very good. We've got one more section to go through, which is linear simultaneous equation. Then we're done for today, so we'll go through the next 2 pages. Yep. Okay, we'll do all the method. Okay. All right, let's move on. All ready? Okay, next. linear simultaneous equation. So we can solve simultaneous equation by drawing the graph, right? So mathematically, we need to find value of pair of polynomials in the equation that make both equations true. There are two main methods, the substitution and the elimination. There's also a method called graphical, but this is not really practical. But we're going to see how it works anyway. Solve them simultaneously. So to do it graphically, it usually takes a long time. What you need to do is to draw the graph. So do a table of values. So 3, 2, 1, right? Plot the point, 3, 2, 1. That's the line drawn. And that line has the equation y equal to 3 minus x. And then we'll draw the other line. X is 0, 1, 2 on y equal to x plus 1. So what do we do? Substitute 0, you get 1. Substitute 1, you get 2. Substitute 2, you get 3. So you get 0, 1, 2, 3. We get the other line. Y equal to x plus 1. So why do we need to draw both lines? We want to get the point of intersection. Point of intersection. And that point of intersection will give you the equation, the solution to this pair of simultaneous equation. Right? So this pair of solution will be x equal to y equal to. And the x is the x value of that point of intersection, which is 1. And the y value is the y value of the point of intersection. So 1, 2, right? They have a common, this is 1, 2. That's common to both equations. Any question? That's solving graphically, but it's very long and it's may not be accurate if they don't cross at a point that is both whole numbers. But it's good to be aware of that method. And sometimes we can use the graph. If they give you a graph, you can use the graph to solve simultaneously. 3 minus x, x plus 1 as a plus.
3 minus x.
Yes, so see that's the equation, 3 minus x, x plus 1. All right, any question? All right, we're going to solve the same question again using substitution. You will see that it is much faster. Okay, let's solve this equation again, which I wrote it at the bottom, using substitution method. The substitution method is when one of the polynomial is the subject. As you can see, both are subjects. So to use the substitution method, all you have to do is to substitute this into the second one. So you see the 3 minus x is now replacing the y, x plus 1, right? So you substitute that y by this 3 minus x, which means they're both equal to each other. And to solve this, you just add x to both sides. So you get 2x plus 1 equal to 3. Subtract both sides by 1, you get 2 equal to 2x. Divide both sides by 2, you get x equal to 1. So we got the x value. How do we get the y value? We sub it back into one of the equation. Let's substitute into the first one. So x equal to 1 means y equal to 3 minus 1, which is 2. So that's it. We've got the same answer, isn't it? But much faster without drawing the graph. Same answer. 1, 2, right? Yeah, or you can just write it together, x equal to 1, y equal to 2. Okay, which also correspond to the point of intersection on the graph. Oops, I don't know what. Okay, all right. All right, any question? Now try the next one. Try the next one. There's another one you have to solve. Now notice that the second one is not the subject. So if I got y equal to 2x plus 4 for that equation 1, x minus 2y equal to negative 5, equation 2, you pick the one where y is the subject, see y is the subject, and replace it by this y. Okay, so we substitute equation 1 into equation 2. So from equation 2, I'm going to replace that y by 2x plus 4, right? This y here is now replaced. It's been substituted by the other equation. And then we solve the equation. Because once you substitute it, there's only one polynomial. And solve for that value of that polynomial. So you do so by expanding first. Minus 4x minus 8 equal to negative 5. Collect like terms, so negative 3x minus 8 equal to negative 5. And you add 8 to both sides, so you get negative 3x equal to 3. X is negative 1. Alright, any question? Now what do we do after we find x? We have to find y. Now which one do we choose? We choose the one where y is the subject. It's easier. So from 1, y equals to 2x plus 4. Replace that x by the negative 1 you got from before. So write y equal to 2 times negative 1 plus 4. That will give you 2. So the answer is x is negative 1, y equal to 2. Okay, question. Alright, that's substitution method. And then we'll have to show you the last method called elimination. Alright, let's go to the next one, elimination. Now, for elimination, they are both not the subject. And this is the best when you use elimination where none of these are subject. So you just write it like this, where both polynomials are on the same side of the equation. That's when elimination is the best. So how do we use elimination? We'll try to make sure that the coefficient of one of the polynomials are the same. In this case, let's make y the same as this y. So what we do is, to do so, we multiply it by 2. So if I multiply equation 1 by 2, we get 4x plus 2y equal to 16. But we have to give it a new name because it's a new equation. And because I changed 1, I can't use 1 again. It's been made redundant. We're going to use equation 2. Okay? So we're going to solve these simultaneously using elimination. So write 3 and then 2. Now, why do I make the y the same? Because if I subtract them, they will be eliminated. So if I do 3 minus 2, I do 4x minus 3x, which is x. 2y minus 2y is 0. 16 minus 13 is 3. Got it? But if not, I just write down the working out. So what I did is, I did 4x minus 3x plus 2y minus 2y equal 16 minus 13. So the y gets eliminated, we get x equal to 3. Yep. Yeah. Once you find x, we have to substitute into equation 1 or 2 to find out the y value. See, there's a y. I'm going to pick equation 1 because it looks easier to solve. But you can still pick 2 if you want to. So you write from 1, we're going to substitute x equal to 3. So you write 2x plus y equal to 8. We replace the x by 3. So we get 2 times 3, that 3 there, equal to 8. 6 plus y equal to 8. Y equals to 2. So we get 2 answers, x equal to 3, y equals to 2. Any questions? Try the next one. I'll try the next one when you're ready. Next one a little bit harder, but we can still do. Okay. Alright, let's look at the next one. So let's write them down. So you get 3x plus 5y equal to 13, equation 1. Negative 2x plus 3y equal to 4. Now you notice this one, I can't just change one equation, you have to change both. So what I'm going to do is, let's make the x the same, the coefficient of x the same. So it's like finding the lowest common denominator. So equation 1, because that's 2, I'm going to multiply by 2, right? So if I times equation 1 by 2, I get 6x plus 10y equal to 26. Equation 3. And for equation 2, I'm going to multiply by 3 this time, right? Because that is 3, so I times equation 2 by 3. So I get negative 6x plus 9y equals to, times by 3 is 12. So what we do is we get, now the coefficient of x are the same, isn't it? But they are opposite. If they're opposite, we're going to plus them. Then they will cancel. We're going to do 3 plus 4. Equation 3 with equation 4. And when we add them, the 6x plus the negative 6x gets cancelled. And then if we add these two, we get 10y plus 9y equals to 26 plus 4. So this gets cancelled, gets eliminated, which means so I get 19y equal to 38, which means y equals to 2. And once you find y, like before, find out the value of x using equation 1 or 2. And then I'm going to use equation 1. So you say from 1, 3x plus 5y equals to 13. Replace y by 2. So 3x plus 5 times 2 equal to 13. No, that's 13. Which is 3x plus 10 equal to 13. 3x equal to 3, x equal to 1. So we get these two answers. Okay. Any question? So today you'll do 2 exercises. One exercise on simultaneous equation. The second one on, the first one is on quadratic inequality. I recommend you to do at least 5 to 10 questions each in order to complete the practice. Done. Okay. If you have